Let's have a look at a demo of the production process. In this first view, we have the executive dashboard where we track the company's performance across 19,000 cases. This dashboard provides us with a high-level overview of how our process is doing, and we can drill down into any issues and use this to inform our optimization strategies. We have clustered the process into two areas of interest, productivity and rework, and for each cluster we have selected the most important KPIs. What catches my eye today is the high rate of multiple inspections. So let's put our analyst hat on and try and figure out what's causing this KPI to underperform. Now we are looking at the Process Explorer, which visualizes how our process runs in reality. Based on a timestamp, case ID, and activity, Celonis gives you an X-ray vision of how your process is executed, including the most frequent activities and connections, starting from machining all the way to inspection. And by default, we see the most common process path. What's interesting to note is that it takes on average 5 days between machining and blasting, which delays the process right from the start. And if I unveil more process paths, we can see additional activities appearing. In the second most common path, we can identify a failed inspection with additional welding and grinding, requiring additional effort and increasing the throughput time. If we increase to the full picture, we reach the spaghetti bowl diagram. The process looks very messy and very complex, but it also shows tremendous potential to standardize and clean up the process. Celonis helps you identify which inefficiencies have the highest business impact, and those are the ones we are going to tackle first. We have seen how the process really runs. Now let's compare how different dimensions affect our process to identify violations and deviations from our desired execution path. In this view, we benchmark different product groups against each other, and we can see the metrics are different for each product group. We can also compare different buyer groups and materials in this section. It's possible to benchmark any dimension, and if we jump to the next sheet, we can see how our process execution differs at different points in time. For an example, let's compare the process in the beginning and the end of 2021. In this case, we can see that there have not been significant improvements in our KPIs. Using Celonis' benchmarking capability, it's possible to identify an internal best practice, a desired process path, and export it to the process repository. From the process repository, we can add it to the conformance checker and compare all cases against it to find out where and when we have violations. There are 4 ways a process can be selected: either from the process repository, uploading it from a third-party tool, creating it from scratch, or mining it from the Process Explorer. So if we jump to the conformance checker, in this case we have 56% of the cases conforming, and one undesired activity is machine test, which increases the throughput time with 16 days. And with one click, we can perform a root cause analysis to identify where and when this is occurring, so that we know what we have to do in order to eliminate it, which takes us to the productivity deep dive. At the top, we can see the selected KPIs, and to the left, we have the process flow. If we take a closer look at the product group with the highest throughput time, we can observe the activities with the highest lead time, which is the time it takes to perform that specific step. For example, subcontracted electropolishing takes on average 313,000 minutes. And to the right, we have a drill down which provides us with the average throughput time for each of the materials. With a few clicks, we are now looking at the process flow for one specific component within a specific production group that we have identified to have higher delays. And up to the right, Celonis has identified the top inefficiencies, consisting of high queue times, manual work, and stock components. Let's take a look at the high queue times. High queue times increase the manufacturing lead time and work in process inventory, as well as the inventory cost. The average queue time is 2 days, and we have 89 cases waiting in queue over 30 days. Subcontracted electropolishing has the highest queue time with 26 days on average. And identifying where we have the highest queue times, gathering all the insights, enables us to take action to fix this inefficiency. And this is where Celonis action flows comes in. We have a very user-friendly, low-code automation platform with pre-built actions for over 800 different applications. In this simple example, we identify components that are more than 30 days in queue. If it's past 50 days, we send an email to escalate this and provide the necessary information. Otherwise, we send a message on Slack to notify and create a task. Here we take advantage of intelligent automation and only involve our experts where truly needed. Every business user has their own task inbox with tasks assigned specifically to them. And let's have a look how such an inbox can look like. The task inbox provides our employees with prioritized tasks so that they are always working on the most critical and urgent tasks. In this example, we have received an alert for high queue times, and Celonis will provide all the necessary information to understand the context and also recommend some next best steps. For an example, investigating further, emailing the line manager, or changing the SLA. And these changes can be made directly in the source system with one click in Celonis. If we would jump back to the analysis, we can also have a look at the rework analysis as well. Here we have a breakdown of how rework is affecting our process execution. We can see that all shifts are similarly affected by it, but let's filter on day shift since it is slightly higher. We see that the rework rate has been consistently rising over a year, and this shows we need to take action to break the trend. On the top right, Celonis has identified the top inefficiencies in the rework area by showing us the occurrences of that activity along with the average throughput time. So let's take a look at the reworks. It occurs when a component needs to be repaired, requiring additional labor and material, resulting in unwanted energy consumption and increased operational costs and wasted time. We are provided with breakdowns of which activities and materials have the highest rework rates, and activity welding has the highest rework rate of 53%. The next step would be to investigate what is causing all of that rework and additional time and effort spent. And a solution to a problem might again be to set up another action flow. So to summarize, what we've seen in this demo is how we start with a high-level process overview, identify gaps and inefficiencies in the process, do a deep dive analysis to gather necessary insights, and then create action flows in order to close those gaps automatically. We involve our experts only when needed and receive best next step recommendations in order to improve our KPIs so that we reach our organization's targets. Thank you for your time.